Hey everybody, Shawn Tierney here from the Automation Blog and School with a very special edition of the Automation Podcast. To celebrate our 100th episode, I reached out to 5 of our previous guests from the biggest names in the industry and asked them to come back on the show, but this time to discuss their thoughts on what the future holds for industrial automation. Now, because this extended episode covers so many different topics, in the description I've listed each guest's name as well as the major topics they discussed with links to those topics. Now that said, our first guest on this episode is John DeTillum from Siemens, who discusses how far we've come, as well as his thoughts on the future of control system architectures, virtualization, and edge devices.
John, thank you for coming back on the Automation Podcast, especially coming on a 100th episode to talk about the future of automation. In the pre-show, we were kind of tossing around some of the ideas that we had talked about in the past, but I really just want to open the floor to get your opinion on where you see automation going, maybe where we've been and where you see us going in the next 5 or 10 years.
Yeah, thanks, Shawn. I really appreciate being part of any of the podcasts or video podcasts that we do with you on the topics that we do. I do think it's pretty interesting to kind of consider, what's on the roadmap, what's the future technologies that we're going to see play out in the world of manufacturing and the world of industry automation. And a lot of times I like to look back because, as you know, you and I and some of the others have talked about some of the things that we've experienced in the past and how it has evolved to the level of where it came from the traditional mechanical machine designs with a little bit of automation, relay control into the PLC to where we are today with automation and the big pitches of the topics that we see going forward. One of the, I kind of like to break some of the Industry 4.0 or digitalization topics into 2 segments. One is that digital thread or design phase where we realize the machine. And the second part is the in production and the analytics and the data and the information of actual in production. So sometimes I like to kind of break that out. But I think some of the key things that you see the suppliers doing is bridging that digital thread of how you do the mechanical design or the process design and the tools that you use from a machine build. If I'm a mechanical engineer or a process engineer that's building the machine, and how those tools have evolved so significantly in the software environment that allows an interaction or a collaboration with the automation and the electrical, so that I can do so much more in the virtual world than what we used to be able to do. And I think that's one of the biggest kind of steps that takes time for the end user and the OEM to evolve into, is that concept of digital twins, virtualization of the machine and of the automation, and of the two of them playing together, so that the automation engineer works together with the mechanical engineer.
Yeah, that makes a lot of sense. Absolutely.
So, I mean, back in my day, I felt like we kind of winged it on the automation. We kind of did it according to what was needed on the machine to work through making the machine productive in the real world on the real machine, working with the mechanics that was what was landed and designed without any input as to what was going to be done for the control system. But now I see these guys taking advantage of doing that together in the virtual world before they ever build the machine, which gives them so much opportunity to vet different scenarios and ensure that the mechanical design or the design of the process or the machine is going to be performant to what their expectations are.
Yeah, I think if you go back 10 years, trying to simulate an entire machine just seemed like overwhelming, right?
Yeah.
But over the last decade or two, SolidWorks has become such a and products like it have become such a major part of designing and creating a new product, a new machine, a new system that I think people, engineers, are starting to realize we have all the pieces to simulate it,
Yeah.
and they're all in our library. We have everything 3D modeled. We have everything done. So now we can bring it in. There is still work to do, but we can bring it in and actually simulate our system. So it really, I think that is one of those big next steps that's going to be taken because people are going to realize, hey, we have everything here already.
Yeah. Yeah, that was the biggest thing is, I mean, if you go back 10 years to when, I remember when TI Portal was launched, I think it was 2009, 2010, Siemens was presenting that story of tying the PLM, product lifecycle management tools, such as what we have today, um, NX, Siemens NX for the mechanical design, or the process simulate or the plant simulate. So there's those three different levels of simulation depending on where you're at, from the machine to the process to the actual whole plant. And those tools have evolved so far that, over the last 10, 15 years with Siemens tying that to the automation layer and the digital twin, the PLC Sim Advanced of the 1500. And the other thing that's significant is if you look at TIA Portal and the all-in-one system-centric project, I've got the PLC and the IO and the HMI all in one project. So when I simulate that PLC and then I simulate the HMI is actually being simulated together with the simulated PLC, and the simulated PLCs being tied from a digital twin perspective to those digital twins of the machine, the process with the robotics, or the plant in a complete virtual representation. And then there was always a lot of questions, what about these other systems that can't be modeled in the software tools that are part of that process? And there's another tool called Simit. Simit is another tool that allows you to evolve modeling certain processes and flows and motors and drives so that you kind of start to pull together a whole suite of these software tools so that you're building that whole concept of how do I bring a machine to life in the design phase so that when I build it, I already know that the automation is going to run. So I think we're at a place now where there's a variety of tools that kind of layer on each other that are setting the stage for the future. And another thing is I feel like it's important to look back and think about where we come from, to think about where a company or a vendor is going to go in the future, and what kind of roadmap have they followed, and what kind of roadmap is there for the potential in the future. I mean, think about it. The original PLC was ladder file 2, all traditional ladder logic, right? And a lot of I/O, digital I/O, a few analog. But over the last 30 years, we've seen the evolution of so many devices roll into the PLC, PID control, motion control, all these concepts that used to be external to the PLC in another controller or another device or in mechanics have now rolled into the controller, whatever you want to call it, a PAC or a PLC or a controller. And now that controller is evolving into that PC. And so that's another interesting perspective if you kind of look at how the automation PLC has evolved over time to where it's at today, more than just ladder logic. It's got the other programming languages in it for the workforce of the future. PC-based devices, so your PLC is kind of riding there in a reliable PLC. And where's that going to go in the future? That's another perspective of, where will the PLC and the HMI go as an automation offering in the future?
And I think I've heard so many people say that, well, you're just going to have one controller in the plant, it's going to do everything, or you're going to have one controller in the cloud, or all your control. And I mean, it's so impractical that, and I understand the vision and the hope. And, I think we have to back up and say, first of all, do you want to connect your proprietary system, that's the lifeblood of your company, to the other 8 billion humans and many more billion bots? Because the internet is connected to everybody. And banks that protect trillions of dollars are hacked every day.
Yeah.
So that's one part of that. And the second part is, what about redundancy? What about
Yeah.
maintenance?
Yeah.
There are processes, there are production lines or processes in every facility that are unrelated, you know? And
Yep.
there's no reason. I mean, in some cases there may be a reason, but just for the sake of downtime and maintenance and servicing, it makes sense for control to live locally. And so I don't see a future until we get to the where a manufacturing facility is produced like a product is today, where, hey, you need this product X in this region. We have this standard plant we build from the scratch. It's always the same. Everything inside of it's the same. And until we get to that point, which is I would maybe 50 years from now, I don't know. I
Yeah.
don't see individual controllers for individual processes or production lines going away anytime soon. But what are your thoughts on that? Do you think all the controllers will be in the sky, or every large
No.
facility will have a single controller that controls the whole thing?
No. No. I have a different kind of perspective. Um, First of all, I do appreciate the fact that the technology is evolving just as it has. That the PLC here is getting more and more capable of running complex languages that enable something more elaborate than ladder logic. And that kind of control for a machine, I think, offers more efficient control on a machine level once it's been vetted and a programmer really has done it. I believe that what the potential could be is that control, a mix of ladder logic, a mix of sequential function chart for a process, and a mix of some scripting languages that get a job done, could evolve into virtualization in the local plant, in the local area of the shop, for example. So because it still has to connect to IO, and it still, like you said, has to be maintained and troubleshot and put into production and commissioned as an entity. And the other thing is, if you look at a plant, I grew up in automotive. There's 4 or 5 different segments of that. You've got your engine, your press room, your body shop, your paint, your assembly. Those different areas all require different resources and expertise to bring that together. So my perspective is, I think the automation, you're still going to have the I/O, you're going to still have networking, but I believe that there's the potential that the control is going to reside in more and more IPC type stuff. And the other thing that I really do believe with, if you look at any kind of industrial PC, that I've seen in a plant, in these server farms, or these things that basically are pulling the data out of the machine, I suspect that the potential is that the PLC rolls into one of those setups, and one of those setups is set up with redundancy and security. That's another big thing that you brought up is, I do think that the tool sets, the frameworks such as TI Portal, there's getting more and more user management built in, more acceptance of that, tied to an external system where the user is validated, compared to what's being done in there. So what I kind of envision is that, more and more user management, more and more industrial security, more and more push of that kernel of the PLC being landed in a device that is reliable. An industrial PC that's got some redundant technology built into it, so that they know that that thing is always running and that it has the capability of having a backup. But I don't think that kind of stuff is going to roll up into one big PLC for the whole plant. I still think, like you said, you're going to want to distribute it, and there's still always going to be a use case for these standalone automation systems when you look at cells or systems that are deployed into its own little environment.
Yeah, you know, I think back 30 some odd years ago, our biggest complaint was that every new product a vendor made needed its own software package.
Yeah.
You know, we were running DOS at the time. Not many people had Windows. You know, it was before Windows 3.0 came out. And there wasn't real much industrial software on Windows at the time, you know, before InTouch was created and all that. Um, and so that was our biggest complaint. Plus, there was so many different networks. Every vendor had their own network. Every vendor had their own. Every product had their own network, and it was really painful. It was the beginning of massive user feedback saying, "I want one PLC program package to program all my PLCs from vendor A, vendor B,
Yeah.
vendor C." And so, then we moved on from that. We said, well, now I want a consolidated package that programs all my device products. I want my TIA portal from Siemens to program my PLC and my HMI and configure my VFD and do
Yeah.
more. And I think even before that we had the look, I don't want a separate motion controller for my PLC. The PLC is really pretty smart. It should be able to do
Yeah.
motion VFD and all this, process. It should be able to do all that stuff. Then we moved into, hey, I want TIA Portal or the equivalents from the other companies to be one development environment for all these automation and control devices. And so, and around the same time too, we were trying to convince people to get into virtualization, right?
Yeah.
Because one of the problems was, well, some things on Windows XP didn't work with Windows 2000, didn't work with Windows NT, and so we're like, you gotta virtualize. You need to have multiple operating systems. Now with Windows 10, almost everything works on any version of Windows 10. It's more like you gotta virtualize so you can do a backup. So if something goes drastically wrong, you don't spend hours and days rebuilding a system. You just roll back to a snapshot. And you can take
Yeah.
this image and now put it on a server and have it live in a pool of servers. So you never go down. If one server locks up, the next one just takes over the load. So, we were trying to sell people 10, 15 years ago on virtualization, maybe even 20 years ago, and and
Yeah.
and how it just blew away using Ghost. But today it's like if you don't do virtualization in a new plant at some level, then you're just making things harder on yourself. So I see what you're saying. It's like today I can take a program designed for a small little, like behind you have a 1200, and I can bring that right into my 1500, and I can just like expand on it. So we have these platforms that are small to large, simple to
Yep.
complex, and I could use the same tools to take a small unit and bring it up to the bigger unit, and in some cases vice versa, to make that code. It's almost so. Can you talk a little bit about where you see virtualization from PLCs going? Because I can definitely see the next step being, well, right now we have hardware that can do that, but where do we go from there?
Yeah. I mean, that's what's interesting. If you go back and look at the perspective of, I remember pushing that cart. It was a DOS terminal. I think it was ACS. It was a blue box with a little screen, and I had a drawer full of cables. Series 422 or 232, and a little PIC adapter or whatever that had a different DIN connector, and every machine from a packaging shrink wrap machine to a stacker, they all had different controllers on it, even though they had the same little meatball icon. When we had to deal with them, they were all different. And then the biggest struggle was as we evolved from 2 years in to the next level, the next generation, a completely new thing was introduced. There was no evolution of the what we had done in the past to the next generation. We had to basically start programming from scratch into the new generation stuff. And I sat there on the plant floor. I remember sitting there juggling my network configuration software with my safety configuration project, and a third-party safety controller, to my small PLC, to my big PLC, to my small HMI and my big HMI. I'm like, why am I having to struggle with all these tools? The one thing that I really recognized 12 years ago, 14 years ago, when I saw the concept of Siemens with the TIA, was an evolution of what they had done in the past. So TIA started in 1994, 95 with their S7300s and Semantic Managers and the concept of function block programming, organization of the code, data blocks associated with that, the system-centric approach with the PLC together with the HMI and the network and the IO all in one. So I can see that. The automatic generation of the system diagnostics, to generate the system diagnostics automatically from my configuration, to me, that's huge. So you're starting to get automation tools that do the work for you. So instead of mapping status bits from the IO in the register to my alarms and mapping them to the HMI, it becomes part of my system. And that's what, is significant to me and why I'm so switched on to the concepts of the Somatic and the TI portal, totally integrated automation. And the portal is the fact that it is a system-centric approach. It simplifies it from the small and the basic with the HMI, the IO, and the networking with system diagnostics, with simulation. It's always had the simple PLC sim to allow you to simulate the HMI, the PLC, and it's ready to blow out to go into the future. So as it evolves over time, whatever happens to the concept of the PLC as it rolls into being downloadable to a PC, the HMI being virtualized in other devices and blown out into components where I need to visualize HMI, the networks being on Ethernet with Profinet technology. I've visualized the fact that this platform is positioned to specifically support that concept as it evolves. Edge is another big thing. Siemens' vision of the edge is more similar to the concept of what you see the smartphones, the devices that, it's a device that sits there giving you access to information, and it may not necessarily be branded Apple or Samsung. That there's technologies and applications that exist that are going to accentuate the power of what I need to do at the device that Apple and Samsung can't provide, but other visionaries might have, concepts of what to do it. And that's what Siemens sees when it comes to applying the concept of edge to the automation system, is an ecosystem that allows that secure, reliable connectivity to the automation layer, whether it's the PLC, the network, the HMI, to access information, and then put an app in there. And an app could be something as simple as pulling all the hardware and pulling out the revision number and the catalog number and tallying up that information in an edge type app that comes from vendor XYZ that's doing this for other automation components and has the know-how to pull that critical revision data of the PLC and the IO and the network and the HMI into the app and then feed that up to the cloud. And it could be a local cloud in the plant. The system could be set up where I've got the edge technology close to the edge of the automation, where it's got access to the data and the information, pulls it up to a control room in a body shop, for example, and then pulls it up to the headquarters stuff. So the edge ecosystem, to me, it replaces that old school data concentrator or system integrator that we used to customize into every plant. We pay a whole big chunk of money to fund somebody to come in and collect my manufacturing information system from all my PLCs, collect it into a system, publish it for production to understand what's going on. And then after we got launched, we had to keep the guy embedded in there for the next 3 years until because nobody else could support his code or his solution, or we had to have him keep coming back. To me, the edge apps and the edge ecosystems offer the ability to see something available on the store and recognize that it could be an application that I need for my plant, and I deploy it to the automation system, and it accentuates the power of my automation system by adding on this additional little concept of what the edge can do.
Yeah, I think, a lot of people say, well, isn't that what libraries do? And really, I think of a library as really a folder of, either blocks of code or projects or parts of projects. I think, with the Edge, that app store, whether it's a worldwide store or a private store or a local store, this is more of the app model from the phones where you'll have a block of code. Maybe it goes with a pressure transducer or maybe it goes with an OEM's machine, a packager. And there's a block of code there that you can, if you buy that machine or you buy that transducer, you can get out of this repository that's updated automatically and put into your code, or it could even be a full-blown app if it's on your unified comfort panel. It could be actually an app that does something cool, a report, like you said, data concentrator reporting package that you buy out of the cloud from your favorite reporting company, and it just works, from scratch, just like an app on your Android phone works from scratch. Your app for your unified comfort panel, you buy it, and it runs on it works with your HMI screens and just all natively, and maybe has a subscription model, maybe has free updates, but it's much more than a library. Does that make sense?
Yeah, it is much more than a library. A library is, I take a sample object and deploy it and parameterize it and run it against motor 1 or drive 2, conveyor 7 or whatever. Yeah, so it is different than the library because the library is going to reside as a component of my HMI or my PLC, or connected to my drive. But picture the Edge ecosystem as a separate device that is connected here, PC type technology, Internet of Things 2050 or whatever device that is specifically designed to be an edge device that's connected to be updated, like our phones get updates. But the Edge app is actually kind of already self-contained and functional. And all you kind of do is parameterize it. Hey, here's my automation project, my IP address or my Profinet name, and it's automatically going to execute its code that has already been done by its developer, for example, and it's just going to do its thing. And like you said, it could be that it's a XYZ vendor that is helping end users collect the firmware revisions out of their devices, whether it's a Siemens or XYZ or another one, and they have a common app that works with any automation hardware and knows how to connect through the IP address, identify what it is, catalog number out of the hardware, revision number, create a nice little faceplate and share that data. Or it could be an OEM that has a motion control application, a special design functionality that is food and beverage or automotive that has some special process that's in the automation with the HMI, and they design an app that fits onto the system that provides some kind of quality information or some kind of productive information or some kind of maintainability. And, it could be something that pulls the information out of the automation system and provides the preventive maintenance that is required for it. It's kind of open-ended to the level of what can be done. And it's a huge opportunity for entrepreneurs that, think, I don't want to do that in a PLC. It should be ancillary to the system. I want to create an app for that. And once the ecosystem exists, I mean, look at our phones, all the apps that we have access to from, the ability to identify poison ivy in our garden with the click of a phone. It's amazing the different things that have evolved in our commercial or in our personal lives when it comes to the devices and the apps. I think the same thing is going to evolve in the next few years when it comes to deploying the edge technology. And then the other thing is the potential of that information being fed back to the design environment. I mean, that's the other big kind of creative potential is my design environment's going to be constantly getting the feedback from the machine that verifies what I did in the mechanical design in this digital design tool. I want some kind of app or data analytics coming out of the machine to verify the whole product life cycle of that machine and the process. And it's baby steps. It's just like we did adopting the PLC over the relay and adopting safety into the PLC and adopting Ethernet and wireless Ethernet into the automation layer and HMIs. I mean, we had struggle getting the HMIs into the plant because they didn't believe that the operator would be able to change pages compared to the console. And the other thing that I think is significant is the workforce that's coming into the workforce of the future. This generation, those guys are familiar with these kinds of technologies and devices and programming perspectives that they're going to be pushing the limits of, hey, why can't I do this stuff? And what can I do in the industrial environment? And that goes back to your other point that, in the manufacturing world, you're still going to want it to be industrial. You're going to want the stuff to be industrial grade, 30-year life cycle, secure for the plants.
And with that, John, I
Well,
want to thank
Shawn.
you again for coming on the 100th episode of the Automation Podcast. And it was excellent talking about your thoughts on the future of automation.
Thank you so much, Shawn. I really appreciate it.
My next guest is Ira Shop from Phoenix Contact, who discusses his thoughts on the future of open automation, as well as equipment as a service.
Ira, thank you for coming back on the Automation Podcast and for agreeing to come on our 100th episode. I really appreciate that. Now, before we jump into talking about the future of automation, I'd like you, just for those who didn't see our previous podcast on PLC Next and all of that, would you mind just briefly telling the audience what your role is at Phoenix Contact?
Sure, Shawn. And first, thanks for having me back. It's awesome to see this hit 100 episodes. Absolutely amazing. And for those that didn't catch the previous time that I was on, I'm the director of marketing at the company Phoenix Contact, which is an industrial component manufacturer. Been in business almost 100 years now. And my responsibility is for all of the automation components in the United States, from control systems to safety to process infrastructure, network infrastructure, cybersecurity, basically any of those smart network infrastructure components as a whole, I'm responsible for with my team in the US market. And definitely really enjoy talking about all things automation and looking at the future of automation as well.
Well, and that brings us to the topic of open automation. Now, we've seen in the past, right, when it comes to the PC market and how originally it was very closed proprietary systems, and then it morphed into this like open standard. And then we saw that with XML, even, years ago, Microsoft jumped on it and they were saving their documents as not proprietary, but as XML, as an open a source type of format. And going into the future, I can definitely see industrial automation going that way, and programmable controllers, HMIs, and other devices kind of moving towards an open architecture or infrastructure. And so I wanted to get you on because I know that's a big thing with Phoenix Contact in your direction. So I was hoping you could just take a moment and maybe look into the future. We don't want any top secret proprietary information, but maybe look into the future and tell us where you see open automation, what the future of open automation is, and where you see it going in the next 5 or 10 years.
Yeah, Shawn. So thanks. And let me get out my crystal ball. Let me shine it up here and we'll figure out where it's going. But open automation is something that I believe is becoming big now and will become much bigger in the future. And I can explore a little bit about how Phoenix Contact fits into this picture, and particularly PLC Next. But before I do that, just to take a step back and look at the idea of open automation and why it is something that is organically growing now, and I believe it'll be growing in the future. First of all, a testament to a little bit of where it's come from. When you look at open automation in the industrial space, there have been some big advancements in a short period of time, where there's a company, ExxonMobil, that actually partnered with the Lockheed Martin organization to do a technology project and to see if they could replace a DCS system using COTS products, consumer off-the-shelf products, and open source software. And the big reason for that was so they could decouple software from hardware and not be stuck to what a single vendor can provide in terms of hardware and software, and really keep up with the Joneses, you may say, in certain software elements. And a key way to do that is to not be vendor locked. And they did this project and it worked out very well. It's since evolved into an organization called the Open Group, and there's there's a project there called the Open Process Automation Forum. And there's actually a set of standards being built towards open automation with a focus towards process control. And as this group has evolved here recently throughout 2021 and now into 2022, there's a variety of producers, particularly in the oil and gas and chemical space, the petrochem space, that have adopted this and have test beds running. BASF, Saudi Aramco, ExxonMobil, on and on and on. There's a bunch of different manufacturers or producers that are running this. And the thing that's really interesting with it, Shawn, is that it again separates the hardware from the software, and it uses open source pieces to this so that there isn't vendor lock. And why that's important is, I said, to keep up with the Joneses. But another thing that's kind of reared its head into highlight here is look at the pandemic and what's been caused in supply chain challenges. By not being beholden to a single manufacturer for the complete system, you can have more opportunity to potentially use a different software package on a different hardware package, making it easier to get components in an otherwise really difficult and challenging environment like we're in today with some of the supply chain shortages. Now, fast forward 5 years from now, will the supply chain shortages still be there? Lord, we all hope not. But the point is, it'll help buffer that space. If this does take hold, it will allow things to evolve in a quicker and in a more efficient way, allowing software to evolve and hardware to evolve, and allow manufacturers to do things in a different way than they were previously able to do. So just kind of a little bit of an overview of where this has come from, some of the validity of to what's actually happening today, and why some things are happening in this space today.
It really follows the model that we've seen over and over again in the past, and maybe the latest model is the Android phone, where any company who wants to make a cell phone can use the Android operating system, and the apps that are created for that system work on all those different hardware pieces. Very similar to the old Windows of technology, and going even farther back, the Open PC, IBM standard technology. So I think that all makes a lot of sense. But with that said, where do you think we're going with that?
Yeah. So where we think we're going with that is, and you had an excellent analogy there with the Android system. And I think it's a perfect example where you can port the same software to many different hardwares. The same would be Windows, right? You can have an IBM laptop, you could have an HP, an Acer, whatever it is. Different hardware platforms can run the same software and ultimately provide similar performance. And there's immense value in that, as I already explained. Now, there is risk in that as well, because then there's different platforms that you have to support. So I think if you look at the cell phone analogy, Android is great, but it's not as stable as maybe an Apple ecosystem is, because it's hardware and software all together. And that's kind of the world we're living in today in the controls world, and for very good reason. It makes things a lot more steady, stable, and secure than maybe they weren't in the past. And an idea of how this will evolve in the future is, I think you'll have a bit of both. So you can have your cake and eat it too, you could say. Where if you look at PLCs today, most of them they draw a box and they do everything inside that box really, really well. But try to go outside of the box and they don't do it so well. So what I would like to propose is, and what I think the future will evolve into, is keeping standard control systems within a box, but leaving a hole in the box so that you can break outside as needed. And an example of that is the PLC Next technology from Phoenix Contact. And the PLC Next technology from Phoenix Contact utilizes a standard PLC runtime, IEC 61131. It's what you're used to: ladder logic, function, block programming, whatever it may be, standard PLC stuff, right? Real time, does all those things. But you also have direct access to the Linux core, and it can support high-level languages such as C and MATLAB and these kind of things, so that you can integrate both the new with the old. You can stay within the box and have a standard PLC, or you can expand outside of the box and integrate new things or open-based things that weren't previously possible. And this can give you so much more capability on the factory floor to do all different kinds of things, whether it be more advanced analytics, it could be more connections to various cloud systems, potentially some AI, machine learning, uh, solving some MATLAB Simulink models, whatever it is. The world is your oyster because you have a lot more flexibility that wasn't previously possible.
Ira, one thing I wanted to talk to you about is I wanted to get your feeling about if equipment as a service is going to be part of our future. We all see the advantage of software as a service, right? Where we have Microsoft Office, you get everything they have to offer for $15 a month, including, cloud backups and just a phenomenal level amount of software, just a phenomenal package. And you have the Creative Cloud from Adobe where you can get software development tools like Premiere Pro and Photoshop and other packages for $49 a month. Do you see that translating to equipment as a service?
Yeah, so, this is an area where I believe there's going to be a lot of growth in the future. So getting on my crystal ball and dusting that thing off, I think software as a service has really paved the way. Uh, you look at IT, and there's a lot of as a service models there, whether it be, infrastructure as a service or even IT as a service, a lot of software as a service elements to it. But in the manufacturing space, I would say largely it hasn't been as well accepted as it's been in other areas, and there's good reasons for that. I mean, typically the manufacturing and industrial industries are slower to change than other areas, and there's a lot more at risk because of the elements being produced are really the lifeblood of the company. If you're not producing more of your widgets out the end of your manufacturing line, nobody is making any money. The company is there is a critical element to making sure you're producing things well. But looking at equipment as a service, there's a lot of advantages. There are some disadvantages, and a lot of that has to come around data privacy and connectivity and security. But I see equipment as a service being a big growing area. And I know there's been many studies done about this, and some of the metrics that I have show that like by 2025, this will be a $131 billion industry growing from about 22 billion in 2019. So it's got a massive potential to it. That's a 35% CAGR that's on that cumulative annual growth rate. So it's poised for growth. But why? What is it? Equipment as a service is really getting equipment in, and you're paying for it maybe per use, per month, per year, per whatever, but you're paying for it as you use it. And one of the big things from the asset owner perspective, from a manufacturer perspective, is that if you're making potato chips and you get a piece of equipment as a service, that becomes an OpEx expense versus a CapEx expense. And that can help from an overall finance point of view. But that's not all. When you look at actually maintaining that system, in most cases, when you get equipment as a service, the dependence is on the equipment manufacturer to do the maintenance, to make sure it's running at peak performance, and it's in their best interest to keep everything running at peak performance versus the manufacturer. And that can become important because we all know that there's been a large amount of retirements that are happening with the baby boom generation. And there's a lot of inherent intellectual property that's going along with them. There's a lot of maintenance pieces that are going along with them. And we're trying to fill that up as much as possible as new people come in, but there's a gap. And this whole pandemic thing didn't help things because there's even a bigger gap because a lot of people have been out of the office and out of the factories for periods of time. So we haven't been able to transition as seamlessly. Then you add into it the great resignation that comes into play where maybe people were working from home and they don't want to go back to the office and all these other things. So there's not as many people as there once were, or at least can be more challenging to get people to do some of these jobs. Maybe on the factory floor, it's not quite as apparent, but definitely on the engineering side, it's happening. So by utilizing equipment as a service and depending on the equipment manufacturer to do a lot of the maintenance and the service elements of the machine, you can really center the expertise in managing that machine and making sure it operates at peak performance with the people that can do it best. And that's the manufacturer. They know their equipment better than anybody else. And again, it's in their best interest to keep it running at peak performance. And there's a lot of value there. So one other thing that comes into play, and I think there's a really good example that's not in the industrial space, but I think it's evidence of as a service type of things that can really evolve over time, is look at Tesla. Tesla doesn't necessarily have an as a service model, but when you buy a Tesla, you're buying a car. It has a very robust automation control system in it. And the neat thing about a Tesla is it actually gets better over time in terms of how it operates and how it works and being able to get new information. And it does this by collecting lots of information on how people are using the machine, using the car as they move around. They go back and they add it to their algorithms, they change their algorithms, and they push all those updates down to all of the cars. And this constantly makes the machines, the cars, better and better over time. Why can't this happen in manufacturing? If you're making a conveyor system or you're making a particular rotary or a bottling line or whatever else, how can you make that better? Well, it's possible you can collect lots of data from real use cases of the machine to figure out where it's doing things really well and maybe where things need to be improved. Then over time of maintaining those machines, you can collect that information and then push that out to all of the machines over time to make them perform better and evolve over time. And I completely realize this is a radical way of thinking in the manufacturing line, and there are definitely challenges, but I think there is real value in this type of evolution in the manufacturing space from an overall maintenance and management perspective, a finance perspective, and just getting more yield out of these machines, which really lends itself to the Industry 4.0, IoT, digital transformation type of idea of just getting more ROI from the assets that you have today.
When I first heard of equipment as a service, I was like, no way. There's no way. This is ridiculous. I've been to thousands of facilities over the last 32 years. But then as I started thinking about it, and we talked about it, I'm thinking, well, let's take just one case, right? You have this large facility that does injected molded parts, right? And they make parts, they may make Legos or they make other plastic parts, maybe the parts that go in your car for your door switches and your windows and all that. And they get a big order, an uninspected order, an order that comes in that the vendor wants to give them an order for 1 million parts over a year. Now, they can only guarantee a year, right? And so what do? Do you buy a brand new injection molding machine? You already have your existing current business. Are you really going to do that capital expense? There's a lot of weighing that goes on there. You have to weigh. Is it going to be worth the expense to buy a machine that I may not use after 12 months? And then, what if they could call their dependable, reliable injection molding machine manufacturer and say, hey, we want a machine for a year, just like the other machines we have, but we only need it for a year. And can we lease it or rent it from you for a 12-month period? In many cases, that can make that bonus order much more profitable because they're just paying for the machine. They're not having to pay for the whole machine. They're just using it for a year, and so they're just paying for it for a year. And I can definitely see that. And I think one example you talked about was like a shrink wrap machine where maybe somebody gets the shrink wrapping. I mean, shrink wrapping a pallet. I mean, there are machines that do that, and they all pretty much do the same thing. So maybe the vendor says, hey, if you buy the shrink wrapping material from us, you'll give you the machine for free. And couldn't that be helpful if you get some big orders and now you don't have enough capacity in shipping to get everything out the door? So I can definitely, and I don't know, am I on the right track with those ideas or those cases?
I think they're very valid cases, and there's extreme value for the end user, the people that are actually the manufacturing, producing the widgets, because of a lower cost, and the on-demand surge type of manufacturing added capacity that you cited. Absolutely. And then on the manufacturer perspective, or sorry, the equipment manufacturer, there's value there because they can maybe sell that or lease that or equipment as a service, that machine to you for a year, and then give it to somebody else for the next year. So it allows that machine to be more universal for them. And there are challenges in this. There's no doubt about it, particularly on the finance side, because the asset cost is still there. It's just who has it on their books. Is it on the device, or is it on the manufacturer perspective, or is it on the equipment manufacturer perspective? And you're shifting the asset cost, the actual on the books cost, the capex cost to the equipment manufacturer's perspective. So they need to learn to deal with that. There's a lot of hurdles here, Shawn. But I really do think that surge manufacturing that you mentioned, the making machines better than they are today, having people really evolve as that next generation equipment manufacturer, I think it's going to happen. And I really do think that there's a lot of validity to it. Will it be in every application? Probably not. But will it evolve, particularly in small to mid-size manufacturing facilities? I really think it will.
And I think you hit the win-win when you were talking about Tesla, how they use the data from their cars to improve the algorithms in the control system. There's some great 2-3 hour long speeches given by Elon and his employees about how that all works. So I won't cover that here today, but it's phenomenal. And so you can think of the win-win here. Not only does the manufacturer win by being able to get a piece of equipment for a period of time, but the OEM, because they own that equipment, they can collect all the data on how it's performing, and then, like you said, make improvements in the software to make it run better. And now they have real data, because a lot of times it's a one and done. You sell the machine, you leave the site, and you don't know how it's working. And this way, they can actually see it in action for a long period of time and really step up their game to make a machine that works better and makes the customer happier. So I definitely see where you're going with that, and it definitely has in some applications, the opportunity to be a huge win-win.
Mm-hmm. Absolutely.
My next guest is Jeff Brown from Mitsubishi Electric, who shares his thoughts on the challenges of the future to increase productivity and profitability. He also shares his thoughts on recent robotic and control system advancements and how they allow control system engineers more flexibility, help them innovate, and also help them increase the company's top line.
Jeff, thank you for coming on the Automation Podcast's 100th episode. Really appreciate you coming on. I know a lot of the listeners don't realize that when I decided to make the Automation Podcast, to change it to be a show where I interview vendors and integrators and users about what they're doing in the field, what the exciting technologies that they have and what's coming out, that you are my first vendor guest from that point on. That was episode 48. And I think we were talking about Mitsubishi PLCs back then. But I want to thank you for joining the 100th episode, the special that I'm putting together. And I really want to pick your brain from your standpoint and your vast experience in the industry, having worked for multiple different leaders in the industry. Get your thoughts on where you see industrial automation going in the future here.
It is really an exciting time. I think the future is bright. And to be in the field of automation, I'm going to date myself a little bit, but I went through this period in the 80s of high interest rates and job cuts. And that's when I came into this. That time could almost be categorized as the winding down of the Industrial Revolution, if you think about it. We have a saying, and again, I'm dating myself. You might have heard this in the sales world. We talked about smokestack chasers. And in a nutshell, as a salesperson, you used to be able to go look for a smokestack, go there, knock on the door, meet the electrician who's doing something with PLCs, replacing relays, that electrical technician, and you could sell them a trunk of PLCs, right? That was kind of the pre-80s. Well, unfortunately, when I came into this industry and for the last 30 years, we haven't had the luxury of smokestack chasing. In fact, they would tell us, don't do that. I would say the last 30 years have been akin to squeezing water from a stone, right? And driving that shareholder value. We've had massive productivity gains. we made that while automation and robotics platforms have greatly advanced. I mean, look at what we call a PLC now compared to what it was then. If you look on the production side with our customer base, there's been high specialization, and we've taken that to extreme levels. And that's very good for automation, motion control, and safety, because if we have that specialization and you're repeating products over and over again, it's easy to automate. Now, fast forward to where we are today, and we just might be in an environment of redefining, what production is. I think we've been on a race to improve the bottom line, and it's just not as exciting as a race to improve the top line. What do you think about that? I mean, I think we've had massive productivity gains. We have improved profitability, and you deal with these engineers every day, and you train them. To me, it seems like we're getting into a very exciting phase where engineers can start to really innovate.
I would have to agree. I think if I look back and I follow what you were just saying, it was productivity has just gone through the roof. Instead of having, if you were going to use a PLC, you would first have to get a physical manual shipped to you, because there was no web browser. The web browser didn't exist, okay? And so there was CompuServe, but very few people had PDFs. I mean, PDFs didn't exist, right? So you had to get physical documentation. I remember when I first got in the industry, one of my jobs was getting those books out to people. The engineers, as an inside technical specialist, I had to get those. I was sending boxes of manuals, and then they would get it, and I would walk them through how to use it. But also communications. Communications was a nightmare. And even with the advent of Windows 95, it made all the DOS drivers break. And people don't realize how hard it was to print to a printer back in the DOS days in the late 80s, early 90s. So
Yeah.
we now have everything has an Ethernet connection, and the protocol that goes over it doesn't really matter because we all have Ethernet jacks in our laptops. And so we can get so much more done. Every manual's a click away. Every connection is just a single plug, and many times our PLCs are plugged into networks that are connected to Wi-Fi, so we don't even have to plug in anymore. We can just use wireless. So we have become so much more efficient. But I do think it has been a one-dimensional transformation, right? It's like things. It's kind of like our cars. For the longest time, the mileage would get better, they would drive smoother, they would have
Yeah.
less noise, but it was a completely one-dimensional change. And I think that's maybe what you're alluding to. I think we're at the cusp of a change where we can now say we have all this great advancement. Now we're going to start using it in a new way to like putting all the pieces together. We're going to start saying, okay, we're not just going to iterate anymore. Now we're actually going to do something new and better with all this great technology we have. So where were you going? I don't know if I took us off
Oh, yeah,
track.
no, that's perfect. And you're right. Like your comment on going from manuals to the internet and having that information available and being able to get that information. I almost want to call it the great beat down, right? We've just all been beat down. It's like we've been challenged to know all of this new technology and get this information, and we want to do it right. And it's been great, but it's just like, once you reach a certain productivity level, okay, we want more. What else can we do? What else can we put in there? And to your point, like even pre-COVID, and all of this resulting supply chain and labor challenges, we were already on a path where our industry was being redefined. All of the major companies like Mitsubishi made large investments in robotics, software, information solutions, networking, focus on big data, IIoT, concurrent engineering, reducing engineering, looking at simulation, artificial intelligence, looking at configuration versus programming. standardization, just making things easier by having function blocks and faceplates. All of this stuff was going on before COVID hit. And COVID just, accelerated that. And all of this has been placed on these automation engineers, our audience as the focal point. And it's really got them in a seat where they can be the hero, or they can be just another bottom line ones or zero, right? And continue the beat down. But I don't think they have to. I think we're in a very unique position where engineers are the heroes. They have all of these tools available and they're needed by the company.
Yeah, I agree with that. It's always, disturbed me when I've seen engineers squeeze, like you said, trying to get water from a rock. Engineers, I've seen, I don't know how many countless times I've seen engineers who dedicated their lives to their factory, getting up at any time of the night. And this goes for electrical supervisors, technicians as well. They would bend over backwards for the company because they thought they were part of that family, a part of it. And then one day they have a downsize and they get caught. Engineers, educated, qualified, people who bring real value to the workforce, they should not be treated like a line worker, right? And so, yeah, they should not choose to be a zero. They should choose to be the people who make things happen. I remember that famous commercial a few years ago where people walk out of the meeting and they're like, I can't believe they want us to implement our ideas. The engineers that we talk to, the controls engineers, right? And again, electrical contractors. There's a lot of people who do this in industry, but our kind of focus on the automation side is the electrical engineer, the controls engineer. Um, they are the people who make things happen. They can make your plant. They can if they're listened to, if they're followed, they can take a plant from barely profitable to extremely profitable because they can change workflows. They can change how products are made and how they're staged and warehoused and everything soup to nuts. And it's really, in my opinion, it's a shame when companies don't realize how important they are and treat them like a line. You're just a line worker, and I would recommend any engineer who feels like he's being treated like that. There are other places who want you. They want somebody who's innovative, smart, hardworking, and can really help their company, you know, meet the challenges of the coming decades.
Oh, and I love that example of the engineers who went in and they weren't ready for the management to say, yeah, we want that idea. And that really points to my question is how do our listeners, how do they be prepared so they're not in that position, so they're ready when they go into that meeting, and how do we handle all of this focus and attention and capitalize on it? So when that engineer goes in there, they're not taken aback. They say, well, here's the plan, here's what we need to invest in, and here's how we need to do it. And they're empowered. And then they can innovate, and that's good for us too, right? That's good for the automation industry. The investment is there. We've seen a lot of activity in the area of robots as they have gotten easier to program. They're integrated and deploy into applications done by human labor. And of course, with COVID, I've seen a lot of companies in the food and beverage space that they've actually reduced hurdle rates post-pandemic to accelerate robot implementation. An example of this is a certain meat packer that they used to have 6 to 8 individuals packing pork chops, and those individuals could no longer work in that situation, nor probably do they want to after the pandemic. And we have the opportunity to put several robots in that application combined with a weighing solution, because the operator was putting, like, you get pork chops in a pack, and they were proportioning the weights out. So you have this combination of a robot with a weigh scale, with a conveyor system. That's an entire solution. And we're seeing a lot more of that robotics opportunity in the marketplace. Now, the challenge is, back to my original comment, is we've done a lot with specialization in my introduction. We're getting to the point as consumers, we're pretty picky. and we want things done a certain way, and we've increased competition for what we want. So it creates the need for automation to be more flexible. And that's a big challenge because automation has been designed around specialization, right? And high throughput. You design it once, you maybe do some tweaks, but now that's a big part of this industrial change is there's got to be new product coming down the line. I don't care if it's your beech nut, if it's cell phones, if it's right, whatever that new product is, clothes, shoes, it's all customization. The holy grail is the product of one. And that's quite frankly why I got into automation. I was a mechanical engineer and I was doing CAD design. And I'm like, what's this lights out factory? How do you get to that? And there's this whole black hole of us wizards in automation that are getting us there. And the exciting part to me right now is the advances in robotics. We have one partner located in Boston. Their name is Southie Autonomy. And what's really cool about Southie is our robot has 3 lines of code in it. And everything else is handled by their intelligent front end. So they can take a tray packing line that's packing mixed packs of soda cans that an operator would do. And an operator is real flexible. You tell the operator, put grape, orange, and lime in there, and they can do it. They can now do that through a whole software front end, even change products. And the robot learns what to do, it develops its path, and does the work. So those are the exciting things that are making robotics more applicable to these areas that, as you mentioned, weren't really fun jobs to begin with.
That really does improve efficiency. Let me ask you, and this may be a sidebar, and I apologize if it is, but what do you think are the main ways engineers can not be zeros, but really make their value known? You know what I'm saying? What are the main ways
Yeah.
engineers can really step it up and not become a commodity, but really become valued members of their company?
Yeah, it's a good question. And you bring up a good point about the efficiencies created, right? Using the typewriter. Well, what happens now, and I'll relate this back to my beatdown, is I think a lot of engineers have a natural repulsion to think, oh man, that just means I'm going to have to do more in the same amount of time. And when do I get to go home to my wife and kids? So we've gotten this kind of work world where it's like, hey, I work 8 to 5, I got to shut it off because of that. On one hand, I think an engineer, and I'm a technical engineer, you get torn because, man, this technology is so cool, you love this. But on the other hand, you got to deal with this kind of beatdown. So I think the first thing the engineer has to do is just pause and take in the perspective and where things are going and not have that initial, they might not even know it, right? But just don't have that initial reaction that, this is just another, right? You know, at that point, reframe and think, no, there's an opportunity here. And you and I don't have the answer, but there is an opportunity here to capitalize on this and look at what the engineer can do, to play with a lot of new technologies. And I say play because a lot of that's been lost in our industry. And I think there really is an opportunity for the engineer to play and innovate within the company and take some risks. So next is, now that the engineer is kind of paused and can put a plan together and think about how they would respond to that situation, right? That technology, whatever it is, be it IIoT, artificial intelligence, robots, safety systems, new motion control, whatever it is, they can then develop a plan to how they present that. And maybe they need some help. Maybe there's some champions they need on the business side to help them with that. And again, the ultimate goal is so when they pitch that idea, they're not in the position where they're surprised, right? They say, this is what I want to do. Here's the innovation. I would say a big ask is, hey, there's some risk with this. A big ask from management is, what's your risk tolerance around this, right? We got to innovate. Again, this is top line. You're not focusing on the bottom line. You're saying this is top line. And when you start thinking top line, think of your investments. It's all about risk and return, right? It's all about managing the two. So now, instead of just being the bottom line and someone else managing the risk and return, you're starting to think top line. And at that point, not only are you armed as the engineer and the innovator, but you're talking top line. And that's going to be an exciting foundation to develop off of.
Now, let me ask you this as far as the future of robotics, because your company's really in the robotics. And also, of course, your company's into everything that we use in the industrial automation industry. So that it's not like they're a robot only company. So
Yeah.
how do you see in the coming, not I don't want any secrets or insider information, but if you look over across the next 5, 10 years, I mean, everything, we always say everything's getting smarter, faster, cheaper. But do you see anything in the robotics field specifically that we should be looking for as new products and technology comes out across the next decade?
Yeah, that's a good question. I think in the logistics market, we're seeing a lot of, and this is an area Mitsubishi doesn't really play other than partners, is a lot of mobile robotics. So that's really been driven by a lot of distribution facilities, workers in plants, and putting mobile robots in. Now, as a traditional robot company, we're like, a robot should have an arm on it. But it's being redefined, right? It's kind of like the internet was defined on TCP/IP as a de facto standard. It wasn't the ISO standard. Things are being redefined as we speak. So there's a lot of movement on mobile robotics. There's a lot of movement on AI and making robots smarter, like the example I gave. You know, there's this dichotomy right now. Like, I mean, there's a lot of supply chain issues. Let's face it. People have problem getting parts. They want a secure manufacturing base. So on one hand, some people want boring. It's like, deliver my parts and I know it's going to work. And Mitsubishi, as a automation plus robot company, we're boring in a lot of ways within that space, right? As far as quality, compatibility, and delivering on performance goes. And then there's this whole advancements that I talked about on the mobile robotics, the AI side of it, that we're following and investing in. Now back to Earth, and right now, the one thing I think engineers can look at is how robots, as my robot team tells me, it's never provided standalone. There's end of arm tooling, there's vision systems, they're on a stand. They integrate with sequencing as a machine cell, you know, right? They got to tie into a PLC. There's safety curtains. So a robot in itself is a system that involves, we call it all accessories. PLCs, HMIs, VFDs, servos, pneumatics. It's all accessories to that solution. And we've been doing that for a long time. Our robot controller can sit in the back plane of the PLC alongside a CNC, PLC, safety, motion control, all in one architecture. So we really think that automation plus robot has been an area we have continued to accelerate at. And of course, you know, investment in that area is why we don't invest in mobile robots, because we want to have that core and deliver that as a global player into the marketplace.
Yeah, definitely see mobile, AVGs and whatnot taking off big time. That's a huge industry places where industry is increasing. Jeff, is there anything else you wanted to say while I have you talk about the future of automation? Is there anything we didn't get to that you wanted to cover?
No, not really. I mean, in a nutshell, we want to make engineers the heroes, not the bottom line zeros. And we think as a global player, combined with the expertise that we have in automation and robotics, we're positioned well to do that. And the future is definitely bright for our industry. And if any of your listeners are, ever want to take us up on this question and how we capitalize on this, I'm all ears and I'm there to learn and help with them if they want help.
Excellent. Well, thank you so much, Jeff. Appreciate you coming on the show.
Yeah, thank you, Shawn.
Next, we have Tyler Phillips from Rockwell Automation, who discusses his thoughts on the future of digital twins, as well as cloud-based solutions.
Tyler, thank you for coming on the Automation Podcast 100th episode, where we're talking about people's view of the future. What's 5-10 years away, and what they see as changes in the industry. Now, I know you're filling in for Brad, who was on the show previously, but our audience may not know who you are. So could you just spend maybe a minute telling the audience who you work for and what your current role is?
Yeah, thanks, Shawn. Appreciate it. Glad to be here. My name is Tyler Phillips. My official title is Global Emulate 3D Business Development Manager. That's a mouthful, I know. But I came to Rockwell Automation. So I'm with Rockwell Automation. I came to Rockwell when they acquired Emulate 3D. And Emulate 3D is a company that developed and continues to develop and license and support a software applications that's used for creating digital twins in manufacturing and material handling in that space. So I kind of started doing most of the management of that company in North America, and through the acquisition have taken on a more global role within the Rockwell organization to promote that go-to-market, right, with the much bigger footprint of Rockwell, if you will.
Let's talk. I'd love to hear your vision because I think it may have something to do with digital twins. This is one of those buzzwords I hear, but we haven't talked previously. So really anything. We're just talking about where is industrial automation going to be in 5 or 10 years? What are your thoughts on that?
Yeah, and I'll attest for your audience that Shawn is right. Shawn, you're right. We have not talked about this. There was no prep, right? So you said to me, hey, tell me what you think, right? So, and I'm happy to do that. It's everybody comes with their own perspective, and my perspective is deeply embedded in the world of simulation and emulation. I've spent almost 30 years doing that for the most part. Took a few years off and worked with industrial HMI, right? But really deeply tied to simulation and emulation. And it was interesting you asked because we were just at the Modex trade show last week in Atlanta, where there's a massive number of material handling vendors, right? And one thing I said to one of my associates there is, we don't see anything really exciting, it seems like, this year. We don't see anything that seems, what is that new thing, right? We see some AMRs starting to be shown, but they've been around for a while. We see some interesting things from companies that are doing maybe some variations on AMRs. But for the most part, we're still seeing a lot of conveyor and automated storage and retrieval and things like that.
Now, AMR, just for the audience,
Oh, yeah.
be driving.
Yeah. Autonomous mobile robots.
Okay, good.
Right.
Thank you.
So think of an automated guided vehicle, but it is not guided in any way. It's autonomous, and for the most part, they move around on grids, right? So you might see them they're similar to, maybe you've seen videos of the robots in Amazon warehouses, right? The famous one that caught on fire in the UK, and the firefighters couldn't get in because the robots were still working, right? So those are AMRs. But anyway, my point is that as I look to the future, what I see is, and based on what's been happening, certainly through the pandemic and even prior to that, people are looking to eke just the tiniest incremental improvements out of automation to improve their processes. And so there's a lot of work looking at how they can take not only existing systems and improve those, but how they can take new small pieces of automation and put them into existing systems. And that's kind of where my view comes of what we do with digital twins and simulation, right? And how that plays into that.
But like we all know, controls engineers, they always get the short end of the stick, right? Mechanical takes 3 or 4 weeks extra to get everything running. Not their fault. Mechanical things happen. And then the controls engineer has the weekend to get it all programmed. And so they can avoid that if they can take the drawings from mechanical and bring them into some kind of product and then do their engineering there. Am I too far off from the?
No, you're right on, right? All it takes, and the ideal project says that design is going to take. You look at the Gantt chart. Design's going to take this long. Delivery and manufacture is going to take this long. Installation commissioning is going to take this long, and it just so happens they all end on the deadline, right? That's the plan schedule. Well, all it takes is a little bit of flex and movement in design, say, or heaven forbid, supply chain. We don't know anything about that, right? Oh my gosh.
Great point.
Or in the manufacturing or in the installation. And suddenly you're right. The guy or the guys or the people that are taking all the heat is the person that's sitting there trying to verify the controls logic and verify the safety and verify the wiring diagram. And site is mostly a terrible place to be if you're not the person that owns that site, right? It's hot. There's mean people screaming, complaining. Why are you? And so what Emulate 3D does, and admittedly other offerings as well, I'm very kind of centric, focused on Emulate 3D centric, but what it does is it allows you to have an environment that's virtual, that's away from the supply chain, that's away from manufacturing, that's away from delivery. And once a design of any given piece of, say, let's just use some examples. Let's say it's a brand new packaging machine, right? Or it's some brand new piece of conveying equipment that's based on independent cart technology that's going to be inserted in a brownfield, but nobody knows it. They think they know what it's going to do, but they don't know exactly what it's going to do. Those are the kind of things that while all that other stuff is going on, right? You're trying to get parts, you're trying to put them together, you're trying to ship them, you're trying to deliver them. Somebody can be sitting in a nice, comfortable office with a cup of coffee with a quote digital twin, right? We call it an emulation, right? Of that system, of that machine on their computer, and can be testing, how does it work? Do the controls I wrote make it work the right way? Are there errors? When I exercise it through a whole bunch of things that I can't exercise it in real life because it's too dangerous, or because I go through too much raw materials, or I can't shut down the plant for that long, what happens? And we want to increase that confidence interval until it's just as high as we can get it. And then we're ready to go. Now we're ready to commission. And the commissioning, for the most part, then consists of, hey, are the actual wires correct? Do the e-stops work? Right? Is the voltage to all the power supplies correct, et cetera? Not that, oh my gosh, there's a line of code that just doesn't seem to be working right.
Yeah, definitely. Definitely. I think that is going to be part of the future. Any other things you see coming down the pike that you may have a hint at that might be something that we should look for in the coming 5 or 10 years?
Sure. There's a couple other things that as they relate to at least software that we see that I'm sure some of your other guests may touch on, and that we have a lot of interesting discussions about. And obviously edge computing and cloud computing are a topic that seems to never cease. I mean, I think back on my career, right? And it seems like cloud computing, at least as a concept, maybe not called that, is something that has been discussed for decades now, right? And we just keep getting closer and closer to maybe this ideal. But the reason I bring that up as an interesting, and I'm glad you asked, as an interesting topic, is I think there are, we're going to see maybe an interesting divide in the industrial world between cloud computing and local computing. As we work with customers, especially in certain industries and with certain types of automation, we hear very strong arguments against cloud computing for certain instances, right? And they say, no, look, the software not only that runs this machine, but that I use to develop the controls for this machine, in our world, it's part of the machine. It literally sits right here with the machine. And for many reasons, we could come up with a whole bunch of examples. It doesn't need to be or want to be touched by anything else. So although we talk about cloud computing and subscription-based software, and we have things like Onshape, right, where you have now CAD in the cloud, and many other examples, and we're even moving that way with many of our offerings at Rockwell, I think we're going to start to see a divide where I think that we'll see dual offerings, and not necessarily competing, but we'll say, look, are you a cloud-based kind of offering, or are you a I say hardware, although I'm not hardware, but the software really resides right there, if that makes sense. And I think that's one thing that's going to be really interesting to watch over the next 5 to 10 years is, does the promise of cloud computing become the end all be all, like sometimes we talk about it, or is it really just an additional way to support the continued growth and optimization and economy of scale and things like that we're all looking for in automation?
Yeah, I totally agree. I think most of us have adopted the cloud in our private life, but I do understand, and my biggest fear is security. There are so many manufacturing plants that have connected their plants to the cloud and said, now what?
There's even some more practical considerations. There was not too many years ago, a couple of companies that were saying, hey, what if all controllers ran in the cloud, right? We could just distribute controlled computing across the cloud. Well, I mean, even though security, yeah, huge concern. What about just latency, right? If you've got a manufacturing operation and you need real-time control over things that are happening in your automation scenario, imagine what would happen with a simple power outage or a brownout or a network. We see network down all the time, right? How many days a month do we hear about part of Twitter going down, or somebody's, some error? I was caught for a whole day a couple of years ago in a major Delta computer down, and I couldn't go anywhere. I literally sat in the Minneapolis airport until midnight, and then finally went and got the hotel because there was nothing going on. And you think about how that would impact, they say the U.S. is only 2 weeks away from a complete supply chain meltdown. If everything were to stop, nobody could any longer get food after 2 weeks, et cetera. Just think of a manufacturing plant that's running second to second, minutes to minute. If something happens, it's a big deal. So I think you're right. We're going to start to see a definition of that. And I think for many of us that work in the software field, it's not only going to push us technologically, but it's also going to allow us to expand our offerings to meet those needs.
Well, Tyler, I really appreciate you coming on our 100th episode. I really enjoyed the conversation, and I want to thank you again for taking time out of your busy schedule to come on.
Thanks, Shawn. Best of luck to you.
My next guest is Steve Mustard from ISA, and he discusses his thoughts on the importance of continuing education and certifications in the industrial automation industry, as well as how it's becoming more and more important for companies to implement robust cybersecurity solutions in their mission-critical applications.
Steve, thanks for coming back on the Automation Podcast. For those who missed our previous episode, you came on as president of the ISA and were telling us all about the ISA, but you also have a rich history working in the oil and gas industry with control systems. So I thought with your experience, you would be somebody I'd want to ask the question, where do you see industrial automation and controls going in the next 5 or 10 years? And you and I haven't talked previously on what you're going to talk about. So I'm really just like, it's as interesting to me to not only to hear where you think the industry is going, but also what topics you pick up on, because it seems like everybody I interview, they have like this different piece that's really their main interest. So with that said, if somebody were to sit down like I am right now with you and say, where do you see automation, industrial controls going in the next 5 or 10 years, what would be your response to that?
Well, thanks, Shawn, for having me on again. And before I start, I want to congratulate you on your 100th episode. Really great job and really valuable information that you provide to the automation community. So please keep up the great work.
I really appreciate that.
So I have two main areas in the automation profession or discipline that I am particularly passionate about. One is industrial cybersecurity. That's something that I've been involved in for more than 15 years now of my career, more and more as time has gone on, for obvious reasons, because it's become a higher profile issue in the industry. The second thing I'm particularly passionate about is education and certification in the profession too. So I wanted to talk a little bit about those things when I talk about the future of automation. And I think they're actually closely related as well in some ways, which I'll hopefully elaborate on in a moment. So I think let me start with the education side and the certification side. So I personally think that formal education in our profession is a really important thing, and I think it's a much overlooked thing. So I think the consensus is that you can learn a lot online, and no doubt you can, but I think you can't replace the formal element of education, certainly in our discipline, because it's something that you have to really understand the fundamentals if you're going to be involved in designing systems that monitor and control critical processes. And my observation over the years, as I've worked with various people, vendors and end users and others, is that I feel that a lot of the basics are not being taught, or people aren't being exposed to them necessarily. So they might do an education, higher education, but then when they graduate, everything else is pretty much left to on-the-job training. And as I'm sure you're aware with your extensive background, that on-the-job training is great if you've got the right people to train you, but it can be a mixed bag. And so you're very reliant on who trains you in that way. So ISA, of course, International Society of Automation, has been around for more than 75 years now, and one of the big driving forces behind that is that kind of knowledge transfer that is really important. So ISA is a standards development organization. That's a really important thing, but it also provides technical education and certification programs in the automation profession. And I think they're really, really important. I'm not trying to sell training to anybody, but I personally believe that if you're going to work in our profession, you should have the right skills and knowledge, and you should be able to demonstrate them with a certification or a certificate. So I always use this example when I talk about this, which is if you're in project management, there is an expectation for most project management jobs that you have a PMP certification, project management professional. And that's great, but there is no equivalent other than a licensed professional engineer that you have to have in order to do a job in our profession. And I think that's unusual. So you have to have a certification to manage a project, but to program PLCs or DCSs or to implement, safety critical systems, there's no often certification requirements for those things. And so I think that's a mistake anyway, generally, but I think also I want to be able to demonstrate to people I work with that I've got the right skills and knowledge and that I've been independently assessed. And I'd like to have the same reassurance from others that they've got it too. So that's a kind of general thing that I think that I think in the past, there was a culture in organizations where people would be encouraged to join professional engineering societies to improve their skills and knowledge and to network and to learn new things. And because of cost cutting and time saving and all kinds of other things, it's not really something that's actively promoted as much these days in organizations. But I think that's a real shame, because I think organizations can benefit greatly from having certified, competent people who can do a job more efficiently, more effectively, get it right first time, all of those kind of things that are really important in our organizations.
And, I have to say I agree with you, and I think that for all the reasons you mentioned, it has really fallen by the wayside. But it's also there's in society there's this move to be less formal in everything. And I think we need to try to pull people back and say, hey, this is good for everyone. If everyone stays up to date on technology, on best practices, on the advantages of using industry-specific libraries, I think we're at the point now where we're coming through the other side of not just the pandemic, but several other trends going on in society. And now may be the perfect time to say, guys, it's time that we all together collectively step up our game and work together to get to the next level to where we have, you know, we're not, code is less of an art now and it's more of a well thought out, planned process. And I think there are several companies I've worked with that are way ahead on this area, but I think most are in the fight or flight mode. they're in the let's keep the machines running so we can eke out a couple more pennies. And my goal is that more and more companies realize that professional development, you cannot go cheap on that. If you want to be a professional company with real earnings and real stability, then you must have. And they do this. My wife's a principal. They do this in schools. It's mandatory. But so I agree with you. I think that I guess I'm hopeful that that comes back.
Yeah, and you're absolutely right about the informality aspect. You know, the agile nature of things, that's used as an excuse to kind of drop some formality in things. But actually, as you say, it's very important to keep some formality, and you can still be agile in that framework. Your point about coming out of the pandemic and hopefully changing things, I think that's a great point to make, which is that ISA experienced this was ISA's training, ISA's events, everything they did was very much in person, face to face. And obviously, in a pandemic, you can't do that. And so, while there'd been a lot of interest in having things like virtual events and virtual training and modular training, there wasn't a big push for it because in person things were still popular. But once you're forced to have to change things, then you quickly adapt. And ISA was really successful in moving things online, especially the training and certification. And so I've actually seen a really positive impact for the profession as a result, because again, if you're doing in-person training, you can only do it in some places. The cost of doing it in other places is high because you've got to send trainers to those locations and so on. But when you do things virtually, you can do it anywhere. You can do it at any time. If you've got material in modular form, people can consume it at the rate that they want to consume it, probably on the platform they want to consume it on. So if you're sitting on the train and you want to watch a 20-minute module about something, then you can do that. And that whole thing has allowed people to consume the training in different parts of the world and maybe have people do that training and take the certificates and certifications exams that they wouldn't normally have been able to do. So I'm really hopeful too that people don't go back to our old ways of everything having to be face to face, and hopefully we'll learn to live in a hybrid world where, you know, there's some things which work well online, some things have to be done in person, but you can use technology and you can get a better experience as a result.
Yeah, and I want to just throw in there that for the managers, for the business owners, or C-level or upper higher ups in management, please do not discount the fact that incentive for education and certification. 32 years when I first got into this crazy industry, the reason that I started doing some I just got out of college. The reason I started learning about new areas and getting certified in new areas is because they had a bonus program. And I was a young married man with like a little kid. And I was like, hey, money, I'll spend my lunch times learning, spend an hour every lunch learning about, increasing my skills so I could make some money and maybe buy a boat and go fishing or whatnot. So please, if you're in a position to influence this, having incentives aside from the certification itself, incentives, whether you become a tier level tech or maybe a level 3 engineer, or however your organization lays that out, I think that's extremely important to help drive behavior.
Yeah, absolutely. Yeah, and as you said, I mean, this is actually to the benefit of those organizations. You know, we're talking about improved efficiency. We're talking about getting things right first time. All of the things that organizations strive for. So, you know, this is not just an academic exercise. This is actually something that benefits the organization as well.
Immensely beneficial.
Let me mention the cybersecurity side of things as well. So much of what I said about education certification applies to that very specific part of the automation profession, the industrial cybersecurity.
Now, can I interrupt you for a second?
Yeah, absolutely.
One of my biggest fears, literally, if something was going to keep me up at night, it would be that our facilities are still not taking cybersecurity seriously. When we have a pipelines that shut down and people are paying $7, for a gallon of gas, it's like this is preventable. You can prevent these things. So I just wanted to say that before we jumped into your to what you're going to say on this, because I know it's very important.
No, it's a very good point you make, and I've been to many facilities around the world in different sectors over the years, and I remember one of my first engagements related to cybersecurity. I was at MI5 building in London many years ago, and we were talking about the risk to critical infrastructure. And I'm horrified to say that nearly 20 years later, the same topics that we were talking about then are still out there today, the same issues, the same vulnerabilities. And that really scares me. And at the same time, the industry collectively spends billions and billions of dollars on cybersecurity technology predominantly, but also services. And as you pointed out, despite that, things still get hacked every day. And that is because people aren't tackling, in my opinion, the fundamental cybersecurity risks that they have, the really basic ones, the ones that aren't very interesting, they aren't very sexy to vendors. And so, we're talking about people and we're talking about policies and procedures, all that kind of boring stuff. But actually, that's the thing that actually trips most of these organizations up. And that is the thing that's going to let them down. If you look at the incidents that have been reported and you look at the root cause of them, you can trace it back to someone doing something wrong, which is either because they're badly trained or because there isn't a proper procedure or policy in place to manage it, or proper oversight of people, following those policies and procedures. So no amount of technology is going to help you when you have people doing stupid things and, not having the right procedures in place. So that, that's very much, again, about education, right? So I keep talking about education because I think it's really important. But if you're going to have organizations that have these significant risks to the critical infrastructure of the nation, they need to understand the real risks they've got, and they need to be educated in how to address them. So ISA produces the world's only standard for industrial cybersecurity, but there are many guides, there's many frameworks and all kinds of other things available and regulations in some sectors, but there is only one international standard, and that's IEC 62443. And that's been developed for pretty much more than 20 years now. I think it started 2002, and it's not a single document, it's a whole suite of documents which cover all aspects from the cybersecurity management system to designing secure systems to designing secure devices, and then all the associated services that go along with supporting those things. Now, it's great to have a standard, but no one's going to read the standard and work out what they're going to do. They need to be guided in that, and that's where the training and education comes into it. Is like, you've got to go to a class and you've got to say, well, how do I go about setting up a proper effective cybersecurity management system, and then have someone take you through it, and then you can learn how to do that, go back to your organization and lead that program to implement it. So I like you, have been working on projects for many years, and over the years with cybersecurity, what I've seen is that even with new greenfield projects, we're not building cybersecurity in from the ground up as we should be. It's still added on as an afterthought, and many of the vendors that are involved, even major automation vendors, they have that knowledge, that have expertise in their organization, but it's usually limited to a small number of people. And then the rest of them have got some level of information, but they don't have, in my experience, the full knowledge. So in some cases, I've sat in design meetings where it's like sitting with Bob Ross, where he's saying, I'm going to paint a little firewall here and a little firewall there. And that's their understanding of cybersecurity. And, it's much deeper than that. The whole point of cybersecurity, like safety, is you have to have layers of protection. You don't just have a firewall, you have all kinds of other controls that need to be in place as well. And I feel like that part of the education is still missing for a lot of people. So if we're going to improve our safety and security of our facilities, we're going to have to do a lot more in terms of the real foundational education and get people brought up to a level where we're dealing with at least the basics of cyber hygiene in an effective way. If you think about safety, for instance, it wasn't that long ago when safety was a much bigger issue than it is today in most of our industries. And after many high-profile industrial accidents, a lot of things changed. And if you go to any facility today, or if you work in that kind of space, safety is just number one priority for everything we do. And you can't do anything without talking about safety. And I hope one day that cybersecurity will be like that, that you can't do anything without thinking about safety and security. And really, they're just the same thing as far as I'm concerned. Cybersecurity risks and cybersecurity hazards and cybersecurity causes are just contributors to safety issues. So if we can get people to think like that, rather than cybersecurity something that IT deals with, then they'll more likely own the problem, and then they'll take more responsibility for it.
Yeah, I like that analogy to safety because safety has come a long way, and most people are force trained all the safety procedures and protocols in every facet of the plant. So if you work in this particular area, you have to get the training, you have to sign a document, you have to be approved, you have to have that safety training. And I think with cybersecurity, it really needs to come to a same level. Like, why are there all those ports available that anybody can plug into?
Mm-hmm.
Anybody with an Ethernet cable can plug into those ports. Why are you programming our multi-billion-dollar system with your computer that's also connected to a public network? And it's so easy for somebody to hack through your computer and get into our system. Why is the procedure to replace the firewall just to take the other one off the shelf? If the other one hasn't been set up, it's very likely may not protect your plant if somebody in the middle of the night is just swapping out a firewall. So there's just so many things to be considered, and I definitely agree with you. And those are some really great insights. And I do think in 5 to 10 years from now, hopefully sooner than later, we will see security become, I would have thought it was after the pipeline, but
Yeah.
maybe it'll take another, hopefully not, another catastrophe for people to realize that the internet with 8 billion people on it and many more billion pots is not safe and should not be connected to your mission critical networks. And
Yeah.
we know the military is on that, but we need to get the industrial sector, utilities, energy, and manufacturing on that as well.
Yeah. I want to mention another thing as well when we talk about security, because one of the other issues I see is that all organizations exist in some kind of supply chain, whether it be they're supplying to someone else or they've got vendors and service providers providing to them. And the other concern I have with security is that you can do a lot in your organization to make yourself secure, but if you don't address the security in your supply chain, then you're still vulnerable. And I'm staggered often the number of people who tell me, well, that's not our problem, that's their problem. But security is everybody's problem. If you're engaged at all in any arrangement with any organization, their risks are your risks. And we've seen incidents like this before in security. We've seen, for instance, EPCs that are providing services to oil and gas companies be attacked rather than the oil and gas company themselves because they're the weakest link. And when that EPC is impacted, the whole project and support lifecycle for the end user is impacted as well. So it's not zero impact if someone else gets affected and you're in the supply chain.
Now,
So
for our audience that isn't in oil and gas, can you explain what EPC is?
Right. So, sorry. Yeah. EPC is engineering, procurement, and construction. So they're a particular type of service provider or vendor that provides that full turnkey service for an end user, from building a facility to maintaining and supporting the engineering services going forward. So a very significant player for oil and gas companies, for instance. They're very dependent on certain vendors to provide them services, and if they're impacted, if they can't work, if their servers are shut down, if their networks are shut down, then business is impacted. And I don't think people fully grasp that yet. So that's going to be something that we're going to have to address as well. Again, all about education. We've got to bring everybody up to speed, and we've got to get everybody on the same level. One day we'll be able to take people beyond that level, and we'll be able to talk about more advanced threats. But honestly, my experience, we're still looking at people being vulnerable to what I would call intolerable risks, things that really should not be out there right now. And you've explained some of those as you've been talking. So unfortunately, we're still in that position today. Some sectors are better than others, but frankly, they're all pretty bad, unfortunately.
Yeah, I think you almost can sum it up as never assume you're safe. Never assume you're secure. Steve, I want to thank you. Those were two great topics we covered. And I really want to thank you for sharing your insights with us on our 100th episode. I really, really appreciate it. Thank you for coming on.
Yeah, thank you, Shawn. Always appreciate talking to you. And again, great work and congratulations. Here's to another 100 episodes.
Thank you, sir.
And to wrap up our 100th episode, I sit back down with Ira Shop from Phoenix Contact to discuss a free community you can join to continue the discussion about the future of industrial automation.
Ira, I know that there's a lot of people out there who want to continue this conversation about, what's going on today and what's coming down in the future. And, I, like a lot of people, we're just so busy in the day to day, we don't have the time to actually set up some kind of new forum to talk about all these things. So in our conversations, you were talking about an existing place where people can go, share ideas, talk about, current technology and maybe what's coming down the future. And I was hoping you would take a moment to tell our audience about your experiences with the Industry 4.0 Club.
Yeah, thank you, Shawn. And Industry 4.0 Club, I think, is a great place. It's a community of like-minded individuals that really just enjoy talking about automation, Industry 4.0 and its evolution and where it's going. And I think this is, we're talking a lot about the crystal ball and the future of things that are happening in the industrial industry. And I think this community building, particularly online, it's been big and it continues to grow. And Shawn, you building your community, I'm sure you see it as well. But these communities that get together are really great because they can peer help each other and help everybody really kind of come along, become educated, and ask questions. And what the Industry 4.0 Club is it's a group that I'm a member of, and there's about 10 to 15 of us that are regular members of the club, and it's actually on Clubhouse. So Clubhouse, if you're not familiar, it's a social media platform that's probably about a year and a half old now, and it's a really interesting platform because it's an audio only platform, and we host rooms in there Monday through Thursday. Typically, they're 12:30 to 1:30 Eastern Standard, so it's right around that lunch hour for the Eastern and Central time zones. And we simply talk about various parts of manufacturing and automation, particularly as it pertains to Industry 4.0. And what makes it unique and different is it's not just like a podcast. It's actually pretty informal. There is a stage that you can get on, you can talk. So that's more of like the podcast element of it. But there's an element where you can effectively raise your hand on the platform and you can come up on stage and you can ask a question. You can engage in the conversation. You can agree, you could disagree, whatever it may be. And that's what I like about it so much. What I like about it is I'm able to use my information that I've gained through various hours of research or looking into different topics, and I can talk about it. But then it also gives somebody the forum to come up and say, hey, Ira, that sounds great, but did you think about this in agricultural business and how it applies to XYZ? Or did you think about that as we talk about open automation and equipment as a service? And you can create a dialogue with people that you may have never met before. And they're from all different walks of life, all different parts of industry. I work for a component manufacturer in industrial controls. That's awesome. I see a lot of applications, but I look at them from my perspective. I'm not an end user. I haven't been an end user. So hearing from end users and what their pains are, where their successes have been, has been hugely beneficial. And that's something I wouldn't get without that regular dialogue there. And to give you an idea of the Industry 4.0 Club, as I said, Monday through Thursday, that 12:30 to 1:30 Eastern Standard Time, there's several different rooms. On Monday, we have what we call the Women in Manufacturing room, which is really showcasing all different types of manufacturing and it from a women's worker point of view, whether it be an operator, whether it be an engineer, whether it be someone in distribution, sales, whatever it is, but some element related to manufacturing with connection to women in manufacturing. I co-host with Yang Pringle, and we run the Future of Manufacturing room on Tuesdays. And that really looks at the forward-looking area of industrial automation, whether it be protocols and technology or applications and industry examples that we're talking about here today. All different types of things that we dig into. Some of them are great and more on the forefront. Some of them are kind of far out and a little more speculative, but it's great conversations to look at where things are going. On Wednesdays, we have Fireside Chat, which really takes someone that's been really successful in the industry in some shape or form, and we do a deep dive in where they are and how they got to where they are, and what really helped them evolve into their area of expertise, whether it be a subject matter expert, a CEO, a factory line worker, maybe a data scientist, all different types of people we talk to. And then the last one is a day in the life. And that really looks at a day in the life of XYZ person in the industry. So again, it gives you different areas of expertise and different things to think about from an industrial automation perspective. And Shawn, I think we were talking a little bit about it earlier. As a creator in this industry, I'm sure you get tons of information all the time, and it's hard to keep up with it all. So having a place to go and listen and talk and communicate on these areas here and what's buzz, what's going on is a great way to stay informed in a quick, concise way through some simple dialogue. So it's an exciting place to be, and it's a great place for me to be part of, and a great community to be part of as well.
Well, I want to thank you for going over that. I want to encourage our listeners to check it out. Whether you're eating lunch in the cafeteria or you're driving through lunch to go to a meeting, check this out, because I know a lot of us, I mean, the internet's now how many years old, right? It released to the public in 91. I think a lot of us have fatigue with forums and groups, right? The whole text-based thing, and it becomes, the automated bots that come in are trying to push a sales pitch on you. And I think something like this is a fresh new change. And if you want to be a listener only, you can be. You can just stop in and say, I don't need to present today. I don't need to get on the stage. I just want to hear what other people in the industry are talking about and doing. So I want to encourage our podcast audience, whether you're listening to the audio or video, to give it a check out. I will include a link in the show description, so it'll be easy for you folks to get over there. And I personally am going to check it out too, because I know just from personal experience since 1990 that I have learned so much. Most of my knowledge has come from other people being willing to share their experience, letting me look over their shoulder as they wrote designed a control system or wrote a program, or even did silly things like use an Excel spreadsheet. I've learned everything I know. I've come from the community of people willing to share what they've learned with me. And so I just want to encourage people, give back to the community. Let's make everybody more efficient, smarter, and better, and really build that community of working together for the greater good. So with that, Ira, I just want to thank you so much for coming on our 100th episode and sharing that with us, and just want to just tell you how much we all appreciate it.
All right, Shawn, thanks so much again for having me. I think we had a great conversation here, and I think this has been a great episode. So keep on doing what you do. You provide great content for the community, and I'm sure everybody in your audience would agree with that.
Well, I appreciate that, Ira. Thank you.
Well, I really hope you enjoyed our special 100th episode of the Automation Podcast. I can honestly tell you It was crazy insane trying to put this together and edit it and bring it out to you. So I really hope it was worth it. I hope you enjoyed it. Please let me know. Please give us a thumbs up and a sub if you did enjoy it. And if you're listening to the audio only edition, please consider giving us a 5-star review. It really helps us expand our audience and find new vendors to come on the show each week. With that said, I want to remind you that you can get all of my very affordable 5-star rated training over at theautomationschool.com, and you can support the show over at automation.locals.com. And with that, I want to wish you all a very happy, safe, and healthy week. And until next time, my friends, peace.